Hello friends, welcome to UGPG Mathematics. In this video, I am going to solve a problem from GATE exam. For more videos, please subscribe to our channel. Thank you. The question is about matrix and its eigenvalues and eigenvectors. So the matrix is 5, minus 1, 4, 1, and we have asked about the true statements for the given matrix. So the statement A is given matrix has eigenvalue 3 and it has multiplicity 2. That means the eigenvalue 3 is repeated twice and only one independent eigenvector. That means it has this eigenvalue 3 gives only one eigenvector. Now second statement says that the eigenvalue 3 has multiplicity 2. That means the eigenvalues are 3, 3 and 2 eigenvectors. That means it gives us 2 linearly independent eigenvectors. The third statement says that eigenvalue 3 has a multiplicity of 2 and no eigenvectors. That means the eigenvalue will not give any eigenvector for the given matrix. And fourth statement is eigenvalues are 3 and minus 3 which gives through 2 independent eigenvectors. Now you just find out the characteristic polynomial. For that, first write down the matrix. So the matrix is 5, minus 1, 4, 1. Let us say this matrix as A. Now consider the determinant of the matrix lambda I is 2 by 2 matrix minus A equal to 0. That is the determinant of lambda minus subtract 5 minus 1 as it is. No, minus A, that means this is plus 1 and this is lambda minus 1, this is minus 4, and take the determinant equated to 0. So this gives us lambda minus 5 into lambda minus 1 plus 4 is equal to 0. Just simplify it. So lambda square minus lambda minus 5 lambda plus 5 plus 4 is equal to 0. And therefore we have lambda square minus 6 lambda plus 5 plus 4 9 which is equal to 0. And this gives us lambda minus 3 square is equal to 0. Because a minus b the whole square is same as a square, that is lambda square, minus 2ab, that is 2 into lambda into 3, that is 6 lambda with minus sign, and b square is 3 square which is 9. Now this gives us lambda minus 3 into lambda minus 3 is equal to 0, and hence we get 2 eigenvalues as 3, 3. Correct. So the eigenvalue is 3 and which is repeated twice, that is it has multiplicity 2. So the D option is false because it is saying that it has 3 and minus 3 as eigenvalues, and minus 3 is not there, so this is wrong. Now remaining 3 options we have to find out which of them are correct. So just find out the eigenvector for the given for this eigenvalue. So for this you just consider the matrix lambda I minus A and write the system. The system is lambda I minus A. Apply x equated to 0 and solve this system. So this x is just x comma y because the size is size of A is 2 by 2 which is a 2 by 2 matrix. So this 0 is a 0 0 0 matrix, column matrix, and lambda I minus A, you put lambda is equal to 3 and just write the matrix. So the matrix is 3 minus 5 is minus 2, then it is 1 minus 4, and 3 minus 1 is 2. Now you just find out the solution for this system. So to find out the solution, note that this matrix is, you just perform the operation, row operation, R2 minus 2 times R1. We will get this as minus 2, 1 as it is, and write the result in second row. So R2 is minus 4, you take minus 2 times minus 2, so it is plus 4. So this entry is 0. Then 2 minus 2 is 0. And the system is as it is, so we just take xy 0, 0. Correct. Because it is homogeneous system, so there is no change on the RHS. And now we'll get minus 2x plus y is equal to 0. So this gives us y is equal to 2x. Correct. So our vector x, the eigenvector is just x comma y, or xy, the column vector is same as you just put the value of y. So x is just independent and y is 2x. So it is x, you take x common, so 1 and 2. So the vector is, it is the linearly independent vector is just 1, 2, or just write it down. So, and this is just a linear combination because this x gives us the eigenspace generated by the eigenvalue 3. So it has only one eigenvector. Sorry, write this as independent eigenvector because it has so many eigenvectors, namely the linear combination, or just you just take the scalar multiplication of the given vector. So it has so many eigenvectors, but the linearly independent eigenvector is just 1, because these are just all linear combinations of 1, 2. So it has only one independent eigenvector and the multiplicity of 3 is 2. So the option is A, and this is the correct option. Now let us solve another question. The question is about the limit. The limit of tan x upon x square minus x as x tends to 0 is equal to. So to find out the limit, you just note that when you put x is equal to 0, it is tan 0, and it is just 0 because tan 0 is 0, and x square minus x is 0 square minus 0, which is again 0. So this is of the form 0 upon 0, the indeterminate form 0 upon 0. So this limit is just equal to limit as x tends to 0. You just take the derivative of numerator and denominator and take the limit as x tends to 0. This is by L'Hopital's rule or L'Hopital's rule to find out the limit. So the derivative of tan x is sec square x, and the derivative of x square is 2x, and the derivative of x is 1, and minus sign is as it is. Now you just put the value of x, so it is just sec square 0 divided by 0 minus 1, because 2 into 0 is 0, and sec square 0 is 1 divided by, this is 0 minus 1 is minus 1, which is same as minus 1. By the way, this sec square 0, to calculate this, we know that the sec x is equal to 1 upon cos x, and hence sec square x is same as 1 upon cos square x. And this gives us, when you put x is equal to 0, we'll get sec square 0 is same as 1 upon cos square 0, but we know that cos 0 is 1, so cos square 0 is 1 square, which is again 1, and 1 upon 1 is 1, so sec square 0 is 1. and hence the limit is -1, and this is the option.